All right, so let's try another one here. Um, so we are still going to simplify this fraction. Now, because they're the same degree, same index, we can always bring this together, right? We can always merge this together and make this the cube root of 216 x to the 6th, y to the 5th, all over 8x to the 8th, y squared. And the reason why I would want to do that is because now I can simplify my fraction and hopefully just make this whole problem a little bit easier. 216 over 8, let's see, will 8 go into that? I think it will. So 8 will go into 216 27 times. So we're going to get the cube root of 27 in the numerator. Your variables, right? Remember from Algebra 1, when you divide like bases, you subtract the exponents. So we're going to get an x squared down here. And then the y's, again, subtract the exponents. 5 minus 2 is 3. We get y cubed. Okay? Now we can split this back up and go cube root 27 y to the oh, sorry. If we're going to split it back up, we don't need a radical that's so big. 27 y to the 3rd over the cube root of x squared, right? And we still want to look to simplify. Simplify the numerator. 27, let's see, 3 goes into 27 9 times, 3 into 9 3 times. Since, again, it's a cube root, we're looking for 3. It's going to take 3 to break one out. Shoot that guy, shoot that guy. We're going to pull a 3 out. And then the other rule for the variables, we're going to divide the exponent by 3. 3 goes into 3 one time, so we're going to pull a y out with nothing left over. So there's nothing left to put back in the radical. The radical just goes away. And in the denominator, we still have the cube root of x squared because 3 will not go into 2 at all. Okay? Now, normally here we would talk about rationalizing the denominator because you can't have a radical in the denominator. But for anything other than a square root, we're going to go ahead and leave it. Okay, so we're going to be done right here. If it were a square root, we would want to do what we did before, where we were multiplying the numerator and the denominator by the exact same radical. Okay, but we're not going to worry about that for any other root. Okay. All right, so you've got one here to try. So just to kind of give you a nudge, I would look to simplify first and then start splitting up and reducing and simplifying from there. So simplify your fraction first. Okay, but go ahead and work on it. Stop the video, start it back up, and you can check your work. Okay, so like I said, simplify the fraction first. This is a square root. So 48 over 3. So 3 will go into 48. Actually, that will divide out to get 16, right? Now your x's. 3 minus 1 is 2, so x squared goes in the numerator. And then you get y to the 3rd down here. So now you're going to split this up into the square root of 16x squared over the square root of y to the 3rd. You can go into your factoring down if you want. So 16, 2 into 16, 8 times. 2 into 8, 4 times. 2 into 4, 2 times. You got a pair of 2's here and a pair of 2's here. We're doing a pair because it's a square root, right? So shoot that guy, shoot that guy. You're going to pull a 2, and pull 2 2's out. And then your variable, with nothing back in the radical. Now your variable, 2 goes into 2 one time with none left over, so you're going to have an x out here. Nothing goes inside your radical again. So there's no more square root in the numerator. You just got the square root of y to the 3rd down here. Keep simplifying here. 2 times 2 is 4, so we get 4x. We didn't simplify the denominator yet, so 2 goes into 3 one time, so y comes out with a y left over. Okay? Now, I cannot have that square root in the denominator, so I'm going to multiply the numerator and the denominator by the exact same square root, which is y. Okay? 4x will go outside times outside, inside times inside. We get 4x square root of y over y square root of y squared. Well, let's see. The square root of y squared is y, so we actually end up with 4x square root of y over, since the square root of y squared is y, we get y times y, or just y squared. So again, if it's a square root in the denominator, we have to rationalize that denominator by multiplying the numerator and the denominator by the exact same radical. If it's not, if it's a cube root or a fourth root, then we just leave it. Don't worry about it. Okay? All right. A couple of sort of, I don't know, story problem, but geometry type problems, right? So the base of this triangle is the cube root of 16. And the height is the cube root of 6. Find the area of the triangle, and we want to leave this in simplified radical form. Well, the area of a triangle is 1/2 base times height, right? So 1/2 times the base, which is the cube root of 16, and the height, which is the cube root of 6. Now, we can go ahead and multiply all this out, right? I mean, we can try to reduce, we can try to simplify 6, 2, and 3. We're looking for 3 to break 1 out, so that's not going to work. We could try it with 16. 2 into 16 goes 8. 2 into 8 goes 4. 2 into 4 goes 2. So actually, we can simplify the cube root of 16. It takes 3 to break 1 out, so there's 3 2's there. We shoot those guys, and we get 1/2 times 2 cube root of 2 times the cube root of 6. Now we go outside times outside, and we do this for all 3 terms here. So we get 1/2 times 2 times 1, basically. So 1/2 times 2 is 1. And then inside times inside, we get the cube root of 12. So we go to reduce the 12 again. 2 into 12 6 times, 2 into 6 3 times. But since I'm looking for 3 to break 1 out, I can't simplify anything out. So the area just ends up being the cube root of 12 centimeters squared. Okay, so just more radical work. Here's another one, right? Volume. How do you find the volume of a box? Well, it's length times width times height. We just multiply those 3 measurements. The length is the cube root of 42. The width is the cube root of 15. And the height is the cube root of 36. So we're going to multiply all of that together. Highly recommend, because 42 times 15 times 36 is a crazy big number, try to simplify your radicals first. So I'm going to take 42 over here. 2 goes into 42 21 times. 3 goes into 21 7 times. I'm looking for 3 to break 1 out, and I can't do it. So how about 15? 3 into 15 goes 5. 3 and 15 goes 5 times. Not 3 there to break out. So then how about 36? 3 into 36 18 times. 2 into 18 9 times. 3 into 9 3 times. Holy cow. Don't have 3 there either. So don't have a lot of choice. We got to take 42 times 15 times 36, and we get the cube root of 22,680. That we want to try to simplify down. So I'm going to come over here and put 22,680 in a box and start factoring. 2 will go into it, 11,340. 2 goes into that, 5,670. 2 goes into that, 2,835. Oh, no more 2. Let's see, 5 will go into it, into the 2835, and it'll go 5, 6, 7. I think that's right. Let's see, 5 won't go into 567, so 3 will, because 5 plus 6 is 11 plus 7 is 18. So 3 will go into this 1, 8, 9. 3 will go into 189. Yep. And I'm going to bring this over here 63 times. This is a very bad way to do this. 3 will go into 63 21 times. 3 will go into 21 7 times. So now I'm looking for 3 to break one out. There's 3 2s here. And there's 1, 2, 3 3s here. Okay? So we're going to shoot these two guys, shoot these two guys. So we're actually going to pull a 2 and a 3 out. And back inside, we're going to take 5 times 7 times 3. So we get 6 cube root of 15 times 7, which is 105. And this is inches cubed. Okay? A little tougher simplifying, but again, the process is all the same. It's just how many you're looking to break out. Okay? All right, that's it. Homework's out in Canvas. Make sure you get that done by next time.